Welcome back, dear students of class 12 Science. Today we are going to discuss the continuation of our chapter Organic Compounds Containing Nitrogen, and we were discussing about amines. So today we are going to discuss about physical properties of amines, and the first one is solubility. Now, these amines are highly soluble in water. Only the first 6 amines are highly soluble in water. And we are talking about aliphatic amines first. The first 6 aliphatic amines are highly soluble in water because they are polar in nature, and as well as since they contain these hydrogens which are added to nitrogen, they are capable of forming hydrogen bonding with water molecule. Okay? And as the molecular mass of amine increases, what will happen? The hydrophobic part, which is this part, as we have discussed about hydrophobic and hydrophilic part in our previous classes also, as this R group keeps on increasing, and what will happen? Their solubility in water keeps on decreasing. Okay? Now let's come to aromatic part. Now aromatic amines are sparingly, means they are just slightly soluble in water. And as molecular mass of aromatic amines increases, they become insoluble in water. So the second point that we are going to discuss today is boiling point. Boiling point of amines. Now since amines, they can form hydrogen bonds with each other, therefore they remain associated with each other, and as a result their boiling points are higher than those of corresponding hydrocarbons with similar molecular mass. Okay? Now see, whenever we discuss about boiling point and solubility, you have to keep 2 things in your mind. The first one is intermolecular hydrogen bonding with water molecule. If they are able to form intermolecular hydrogen bonding with water molecule, then they would be soluble in water. Now, for boiling point, here also the intermolecular hydrogen bonding is required, but here in case of boiling point, if intermolecular hydrogen bonding takes place between amine molecule and amine molecule, okay, then they remain as what? Associated form. They remain in associated form, means their molecular mass will be more, and as a result of that, what will happen? Their boiling point would also increase. Now let's compare the boiling point of amines with that of alcohols and carboxylic acid. Boiling point of amines are less than that of alcohols or acids, carboxylic acids with similar molecular mass. Why? Because see, in case of alcohol, what do you have? You have OH group. This is the functional group of what? Alcohol. And similarly, here also for carboxylic acid, we have C double bond OH as the functional group for carboxylic acid. And for amines, we have NH2 group. Now this is amine. So this is alcohol, this is carboxylic acid, and this is amines. Now in all these 3 functional groups containing compounds, they are able to form what? Intermolecular hydrogen bonding. But what you have to see? You have to see that the hydrogens of amines are attached to nitrogen. And since nitrogen is less electronegative than oxygen, in both the cases, you see, in alcohol also you have oxygen, and in case of carboxylic acid also you have what? Oxygen. And these hydrogens, in case of alcohol and carboxylic acid, since they are attached to this more electronegative oxygen, what will happen? Here, the polarization of this bond will take place to more extent. And as a result, whenever these hydrogens of carboxylic acid and alcohol are involved in intermolecular hydrogen bonding, the strength of bonding would be more compared to this amines, where these hydrogens are attached to nitrogen. And as I told you, this nitrogen is less electronegative than oxygen. And because of this, here in case of alcohol and carboxylic acid, the molecules remain associated by stronger hydrogen bonding, and as a result we need what? More amount of energy. And when we talk about in terms of boiling point, we need more amount of temperature, higher temperature to break this intermolecular association. Therefore, the boiling points of what? This alcohol and carboxylic acids are higher than those of amines. It has to do with what? Oxygen atom to which hydrogen is attached in case of alcohol and carboxylic acid, but in case of amine, hydrogen is attached to nitrogen, which is less electronegative. So this we are discussing about boiling point comparing alcohol, carboxylic acid and amines. Now let's compare the boiling point of first degree, second degree and third degree amines. Now in case of first degree amine, we have two hydrogens attached to nitrogen. In case of second degree, we have only one hydrogen attached to nitrogen, and in case of third degree, we do not have any hydrogen attached to this nitrogen. Now, so here we can say that this amine will be able to form how many intermolecular hydrogen bonding? 2. This is first degree amine. So since 2 hydrogens are present, so it would be able to form how many intermolecular hydrogen bonding? 1, 2, 2. And second degree, since it has only one hydrogen here, which is attached to nitrogen, it would be able to form only one hydrogen bonding. Whereas in case of tertiary, we don't have any hydrogen. Therefore, now whenever we talked about boiling point, we said higher number of this intermolecular hydrogen bonding, their boiling point would be higher. Therefore, by looking at their number of hydrogen bonds formation by a particular first degree, second degree and third degree, we could easily tell about their boiling point. Since first degree has more number of intermolecular hydrogen bonding, therefore its boiling point would be higher than that of second degree, and at last the least boiling point would be of third degree amines. Hope this is clear. Now let's discuss about basic characteristics of amines. Now we are discussing about basic nature or characteristic of amines. Now we know amines contain NH2 group. Okay? It contains this group, NH2 group. Now since we have lone pair over nitrogen, now this determines this lone pair of this nitrogen determines the basic nature of amines. See, whenever amines are treated with water molecule, say HOH, then what will happen? This lone pair of over nitrogen to abstract a proton from water molecule. As a result, we get RNH3 plus, and what we get? We get OH minus. Now, the basic nature of amines in aqueous solution is because of the production of what? OH minus ion. You know, if a compound generates OH minus ion, then that would act as what? A base. And if a compound generates H plus ion, then that would act as what? An acid. So this shows that amines are acting as what? Basic in nature whenever it is in aqueous solution. Okay? Now let's discuss about basic characteristics of amines in more detail. Since this, as I told you, lone pair of this NH2 group are responsible for what? Basic nature of amines. Now we can tell the basic strength of amines according to how easily it can donate its lone pair of electron for protonation. Okay? So let me repeat it once again. This is a very important point. If an amine can donate its lone pair of electron more easily to abstract a proton or for protonation, then that will act as a more basic amine. Okay? So let's discuss that. Now let's compare the basic strength of a first degree amine, second degree amine, and tertiary amine. So first degree amine is RNH2 as you know it. The second degree amine is R2NH. So let me write this R with different bonds. And for third degree, what we have? We have all what? This hydrogen substituted by R. So this is first degree amine. This is second degree amine, and this is third degree amine. Now here, you see, it has lone pair of electron. Here also it has lone pair of electron, and here also lone pair of electron. Now, here we can consider what? You can consider this plus I effect. Here, since one alkyl group is present, in case of first degree amine, that is one R group, it will show only one plus I effect. But in case of second degree, what we have? We have 2 plus I effect by 2 alkyl groups or R groups. And here in case of tertiary, how many plus I effects are there? 3 plus I effects are present. So whenever, now this is very important, whenever these amines are in gas phase, then obviously we need to consider the plus I effect only. Now more the number of plus I effect, what will happen? They will shift its electron over nitrogen, and what will happen? Now this lone pair will be easily available, because since electrons are shifted towards nitrogen, now the intensity of electron over nitrogen will be more. Therefore, they can easily be donated for protonation. Okay? Now, based on this plus I effect, we can say about its basic nature, which one is more basic. Since tertiary amines has 3 plus I effect, therefore its basic strength would be most among the three. Then comes second degree, since it has 2 plus I effect, and at last comes first degree, where only 1 plus I effect is present. Now, this, please remember, this order of basic strength is in gas phase. Now this is in what? Gas phase. Now let's discuss about the basic strength of these amines in, say, aqueous phase. Okay? Now in gas phase, don't forget, you just need to consider plus I effect. More the number of plus I effect, more will be its basic strength. amines are present in aqueous solution, then we need to consider different effects. Okay? Number one, now we are discussing about basic nature in aqueous phase. Aqueous phase. Now in aqueous phase, we need to consider three factors. Number one is obviously plus I effect, plus I effect, as it was in case of gas phase. Now here, you already know, more the number of plus I effect, more will be its basic strength. And the order was third degree, second degree, and then first degree. Now the second condition that you have to take into account in case of aqueous phase is its stability of conjugate acid. More the stability of conjugate acid, then that particular base would be more basic. Now, this for the stability of conjugate acid, let's discuss in little more detail so that you can understand it better. Now, for this, we need to consider, let's take this first degree amine. Okay, so R and H2. So, whenever it is treated with what? Water molecule, then what will happen? As you know, a proton will be abstracted and you will get a OH minus ion. Now since this is a base, now here this is the conjugate acid of this first degree amine that is acting as base. Now we need to consider its what? Its stability. Okay, more the stability, more will be its what? More will be the basic strength of this particular base. Now since how many hydrogens are attached here? 3 hydrogens. These 3 hydrogens are attached to this nitrogen. And therefore now here, this particular conjugate acid would be stabilized by 3 hydrogen bonds. It would be able to form how many hydrogen bonds? It would be able to form 3 hydrogen bonds. Okay? Similarly, if you consider second degree amine, where you have only 1 hydrogen and again hydrolyze it, then what will happen? You will be getting a conjugate base where you will be having R and H2 plus ion plus OH minus ion. Now here, this is the conjugate acid of this second degree amine. Okay, here how many hydrogens are present? 2 hydrogens. Therefore, this is stabilized by now 2 hydrogen bonds. Similarly, in case of third degree amine, that is R3N, this is third degree amine. So whenever it is hydrolyzed, it would form R3NH plus. This is the conjugate acid of third degree amine plus OH minus ion. Now since this conjugate acid of third degree amine contains only 1 hydrogen attached to nitrogen, therefore it will be stabilized by only 1 hydrogen bonding. Now, according to the stability of this stability of the conjugate acids of this first degree, second degree, and third degree amine, we can say about its basic strength. So, let me repeat it once again. More the stability of the conjugate acid, and that would depend upon what? More the number of hydrogen bonds formed, and that would be more stable. Now, according to this, we saw that since primarily the conjugate acid of first degree amine would be having how many hydrogen bonds? 3 hydrogen bonds. Second degree 2, and third degree only 1 hydrogen bonding. Therefore, we can say that according to the stability, the order will be first degree, second degree, and third degree. Okay? Hope this is clear. This is a very important point. Please note it down. Now, the third point is the steric hindrance. The third point is what? The third point is steric factor or steric hindrance. Okay, now according to this steric hindrance, you know steric means whenever you have a bulkier size. Now, if it has a bulkier size, then what will happen? They will repel each other, repel with each other, and as a result, that becomes less stable. Now, consider the third degree. Third degree contains how many R group? 3 R group. And the second degree contains 2 R group, and first degree contains only 1 R group. Now, so obviously, these R groups are bulkier, means they are bigger in size than hydrogen. Therefore, here, suppose here what would happen in third degree, the steric hindrance would be more, because since the size of this R group are bulkier, means bigger than hydrogen, they would interact with each other. As a result, this third degree becomes less stable. Here, second degree, in second degree, how many R groups are present? 2. Therefore, here also we have steric hindrance. But in case of first degree, we have only 1 R group, and here the steric hindrance would be less. Therefore, according to steric hindrance, the basic strength order would be first degree, second degree, and third degree. Why? Because first degree is having the least steric hindrance. Okay? Now, considering all these 3 points, whenever we take into account all these 3 points in one particular amines like first degree, second degree, and third degree amine, we find that the basic strength order, please remember this one, the basic strength order, if we consider all these 3, okay, considering all those 3 factors in basic strength of amines in aqueous solution, the order of basic strength would be second degree followed by first degree, and then comes third degree. So in aqueous solution, the basic strength order would be second degree, first degree, then comes third degree. So, the next we are going to discuss about the basic strength of aryl amine and alkyl amine. So, the next is alkyl amine and aryl amine. So, alkyl amines are those compounds where we have alkyl group. Okay, and aryl amines means we have NH2, which is containing benzene ring. Now, here, see, in case of aryl amine, we have this triple bond inside the benzene ring, and here, in both the cases, the lone pair are present over nitrogen. And the basic strength is determined by availability of this lone pair over this nitrogen atoms of amine. Now, whenever we look at this aryl amine, we see that since benzene ring is involved here, this lone pair takes part in resonance. And once this takes part in resonance, what happens? This lone pair is not only available here over nitrogen, but it conjugates over the entire ring, and because of it, it is not readily available for protonation or donation. But in case of this alkyl amine, since we have R group and R group shows plus I effect, it shows plus I effect, and because of this plus I effect of R group in case of alkyl amine, what will happen? The electrons over nitrogen is intensified, means it becomes more, and because of it, now this lone pair of electron can easily be donated. Therefore, this lone pair of electron can easily be donated, and because of which its alkyl amines basic strength is more than that of what? Aryl amine. Don't forget, because of resonance in the benzene ring, what happens? The lone pair are not available over nitrogen freely, and therefore it cannot undergo protonation easily. Now let's discuss about effects of substituents on this aniline. Now, in our previous class also we have discussed about electron donating or releasing groups. Like OH group, CS3 alkyl group, etc. So whenever this electron releasing or donating groups are attached to benzene ring, it always increases the basic strength of amines. So let's compare the basic strength of aniline and say aniline where the CS3 group is present at para position. Now this CS3 group shows plus I effect, and because of it, it intensifies its electron towards this ring and towards this NS2 group. Because of it showing plus I effect, what happens? The electron density over nitrogen increases, and hence it can easily the lone pair is easily available for protonation, and therefore its basic strength will be more than that of what? Aniline. Okay? Don't forget, more easily the lone pair is available for protonation, its basic strength will be more. Now let's compare about ortho, meta, para substitution and what is the order of their basic strength. Don't forget, now whenever we have substitution at para position, in case of electron donating group, don't forget, okay, it has the maximum basic strength. Then comes meta substitution, that is CS3. Then comes unsubstituted aniline, and at last the least basic is what? The ortho-substituted aniline, and this is because of ortho effect. We have discussed about ortho effect in our previous videos. Okay, so this is the trend every time. If we have what? Electron donating group, maximum basic strength would be of what? The para substitution, then meta, then comes unsubstituted. Never ever get confused. Ortho has the least basic strength, and because of it's because of what? Ortho effect. Ortho effect. Please remember, whether electron releasing groups are present or electron withdrawing groups are present in this ring, ortho substituted these compounds would be having the least basic strength. The second one is electron withdrawing groups. If they are attached to benzene rings, like NO2 group, nitro group, we have CH4 group, etc. Okay? So now whenever these groups are attached, every time electron withdrawing groups are present, then what will happen? It withdraws electron from what? From this nitrogen compound, that is aniline, NS2. Now suppose you have, say, NO2 group present here. Now what will happen? This NO2 will withdraw the electron from the ring and as well as from this nitrogen. Lone pair of electron will also come in resonance with this nitrogen, and because of that, what? Lone pair is not easily available. Therefore, they always, electron withdrawing groups, they always decreases the basic strength of what? Aniline. Basic strength of these compounds. It always decreases the basic strength. Now let's compare the basic strength of ortho meta para substitution. Okay, in case of electron withdrawing groups. Don't forget it decreases. Okay, electron withdrawing groups always decreases the basic strength. Now, whenever we see this one, since electron withdrawing groups are decreasing the basic strength, therefore, what will happen? This unsubstituted aniline would be having the maximum basic strength. After that comes what? Meta substituted aniline. Then comes this is aniline, para substituted aniline, and the list basic is ortho substituted aniline. Don't forget, this is because of ortho effect. Okay, hope this is clear. This is to be kept in your mind. Now this is very important. Okay? You will be asked question based on its basic strength. And don't forget, in gas phase, what is the order? And in aqueous phase, what is the order? And in aqueous phase, which factors are to be taken into consideration for predicting the order of what? This basic strength of first degree, second degree, third degree, comparison between alkyl and aryl amines. Then comes this electron donating groups, if they are present, they always increases the basic strength. And if electron withdrawing groups are present, they always decrease what? The basic strength. And don't forget this order. Okay, the maximum in case of electron withdrawing groups, if it is attached to benzene ring, the unsubstituted one would be having the maximum basic strength. Then comes meta substituted, para substituted, and the list is what? The ortho substituted. And ortho substituted is because of ortho effect. Irrespective of whether the electron donating group is present or electron withdrawing group is present. Look over here. CH3 is electron donating group, NO2. CH3 is electron donating group, NO2 is what? Electron withdrawing group. Irrespective of its nature, they are having the what? List. They are having the list basic strength. So hope this is clear. We'll be seeing in your next class. Till then, keep revising whatever I have taught you. Take these things very seriously. Okay? Thank you.